All right, everyone. It's 8:36. Let's get started. Can everyone hear me back there? All right. So as you can see, I'm not your normal lecturer. I'm Vin. I am a newbie on app dev. This is my first semester, and today we'll be learning something. Thank you, guys. So today we'll be learning something new. Have any of you guys heard of SwiftUI? A couple of you? Yeah, so throughout the past 6 weeks, you guys have been using this framework called UIKit. It's provided by Apple, but today we're going to change things up and use this, in my opinion, the better framework, SwiftUI. So, what is SwiftUI? So SwiftUI is a declarative framework provided by Apple that allows us to build our user interfaces. Similar to UIKit, SnapKit, MapKit, all of these are frameworks in which Apple provides for us. SwiftUI was introduced back in 2019 as a replacement to UIKit, so it's relatively new. And the reason why Apple decided to shift from UIKit to SwiftUI is because there are less lines of code that you need to write. So it allows for more concise and readable code. And it's a lot easier to maintain and extend, build off of. And that is why SwiftUI is the future. So if you guys are ever interested in app development, I highly recommend learning SwiftUI. So in order to understand the difference between SwiftUI and UIKit, it's crucial that we understand the difference between imperative and declarative. So this is an analogy that I like to use. So pretend you are going to the store to buy some, a piece of steak for some cookout. The imperative approach would be this. I walk into a store, go to the meat section, start scanning from the top to the bottom until I see a piece of steak. I grab that steak, check the price. If I'm satisfied, I put it in my shopping cart, check out, I go home. Right? So as you can see, all of these steps tell me how I should do things. So the imperative approach defines how tasks should be accomplished. So if we connect this back to UIKit, does this code look familiar? Yeah. So I have a view controller, and I have these functions that create some kind of table view. So I set up a table view, set up the delegate, set up the data source, I set up constraints. These are all instructions on how to do something. And you can see that there's a lot of code. But wait, there's more code. So in the view controller, I would extend this UI table view data source class. And then I would need to provide these other functions since I'm conforming to this protocol. And there's just a lot of code. And now this is why Apple decided to switch to SwiftUI, because there's a lot of boilerplate code for something that you can create in less code. So to compare this to SwiftUI, let's look at what declarative is. So back to that shopping cart example. The imperative approach would be go to the store, look for a piece of steak, and then there's just like a bunch of nonsense. I don't care about how I want to do it. But the declarative approach would be go to the store, get a piece of steak. That's it. I'm telling it what task I need to accomplish. I don't care how, I just know that I need a piece of steak. So now if we look at SwiftUI Kit, if you're not familiar with SwiftUI, it's okay. This is, it doesn't make sense at first, but what this shows is that I have some kind of navigation view, I have a list, I have a link to the navigation view, and it leads to a detailed view, and the label for that link would be some text. In the UIKit example, you have all these properties that you're constantly changing, because you're telling it how to do things. But in SwiftUI, you're telling it what to do. Give me a navigation link. Give me a list. Give me a text. That's the declarative approach. So is there more code? That's it. All of that stuff that I have to do in UIKit, I could do it in a few lines in SwiftUI. And that's like the beauty of SwiftUI there. I told it what to show, and I create rules. And SwiftUI enforces those rules for me. So now let's get started with SwiftUI. You guys don't need to follow along for this demo. I'm just going to show you guys how to create a SwiftUI project. So, let's see. All right. So if you create a new project, can you guys see back there, kind of? All right. So I would create an app, and normally you guys would have used storyboard and then remove all that nonsense storyboard stuff that you guys are familiar with. But in this case, I'm going to create a SwiftUI interface, and for the name of the product, I'm just going to call it sample. And that's it. That's all you have to do for SwiftUI. You don't need to remove the storyboard, none of that. Click next. I'm going to put it, just put it right here. All right. So I created my SwiftUI project. As you can see, there's this live preview that I'll discuss a little bit later. And on the left, this is the starter code for SwiftUI. So I'm going to go back to the lecture. Okay. So I kind of just copied all that code over here so you guys can see it a lot better. So on the left hand side, you have this thing called a project navigator, and it just tells you all of the files that are inside of your directory. Sample app contains all the code that is executed at launch, and it's kept throughout the entire app's lifetime. Content view, this is the file that contains all of the code that you're going to be writing. So most of the time, the sample app, you don't really need to write it. It's similar to how you have scene delegate, app delegate, all that stuff. But most of the time, your code is going to be written in contentview.swift. All right, so let's take a look at the starter code inside of content view. And so let's start with import SwiftUI. Similar to how you import stuff in UIKit, you want to import SwiftUI as well, because that's how you get all the functionality provided by this framework. Now let's take a look at this part. Yeah, recording. Oh. Okay. So yeah, let's take a look at this part of the starter code. So I create a struct called content view, and I conform it to the viewer protocol. So anything that you want to draw on the screen, any UI related views, you want to conform it to the viewer protocol. And then I create a property called body, and its return type is some view. I'll explain that in a bit. And note that this is the only required property that you need to have. Because you conform to the viewer protocol, you need to have this body property. And inside of this property, I have a text view with a string hello world. So because this is declarative, you guys can kind of figure out that this thing gives me a text with hello world in it. Up next is this preview provider. I'm not going to go too much detail about it. You normally use this for previews, but honestly, that's not really important with SwiftUI. Live previewing is cool, but when you work on large-scale apps, most of the time, the previews won't work. So I won't go into much detail, but notice that the structure is similar to the structure right here. It's very similar. So there's a struct, it conforms to some view protocol, and it has a property that has a return type of some view, and then inside of that there is a content view, which is another view. So now, what do we notice about the starter code? Well, in UIKit, if you create a view controller, you start with class, I guess my view controller, extend the UI view controller class. But in this case, you guys can notice that there's only structs. So why does SwiftUI use structs for views? Well, as we all know, structs are much faster than classes. And it's because structs live on the call stack and classes live in heap space in memory. So that's why structs are a lot more quicker. And when we're creating apps, we really care a lot about performance. So that's one of the reasons, but that's not the main reason. Another reason is that this is a lot more simple than using classes. And it's because when you create some kind of view in UIKit, you have to create a subclass of this UI view class. And because it's a subclass, you have all of these nonsense properties, all these methods that you inherit. But most of the time, you guys don't even need all of it. And the problem is that these classes are way too intelligent. There's a lot of functionality in them that we don't need. And the issue is that when things are too intelligent, they can get really, really messy. And we want our views to be dumb and simple. The only thing that they should do is convert data into UI, nothing more. We don't want our views to be really smart. We don't want it to have all these properties that we don't want, that we don't need. And so our views need to be just views, nothing more. And everything you see is all of it. So if I want the text hello world to be on the screen, I declare it. Give me a text with hello world. I want the image app.dev logo on the screen. Give me the image app.dev logo. What about a rectangle? Give me a rectangle. Okay. The color red. Give me the color red. In other words, you declare what you want. So these are all, well, not all, these are just a few of all the views that SwiftUI provides. So if I wanted a list, give me a list. If I wanted a button, just say button and it gives you a button. And there's a lot more to it. Yes?
Or can you go back to one? With list, does this combine what is UI table views and collection views?
Yeah, in the demo, I'll actually go over list, but you can think of list as kind of like a table view. In terms of collection view, the thing about SwiftUI, or the thing about declarative versus imperative, many of you guys might think that, using SwiftUI, you may have heard that it's a lot easier, but it may be easier to create views, but in terms of how you program, how you think, it's completely different from an imperative approach. And when you were to look at, I guess, like the Spotify app, if you were to do it in UIKit, you would think, okay, I have a collection view, I have a table view, all that stuff. But in SwiftUI, you have to think of it a little bit differently. And I'll go into that a little bit later. All right, so I can create this view. If I wanted text, give me text. What if I want a red text with the word hello world, a font size of 24, a black background, and a padding of 20? Okay, I can try that. Give me a label, or give it a label of hello world, give it a font size, blah, blah, blah. This is incorrect. This is wrong. SwiftUI views are not smart. This is how you would, I guess, kind of do it in UIKit in an imperative approach, where you have all these properties and you're changing it. But SwiftUI views are not that smart. It can only contain one thing, and that's a string. So how do we create this modified view? And SwiftUI provides this thing called modifiers. And so modifiers are methods that are attached to SwiftUI views. And there's a bunch of modifiers. For example, dot foreground color, font, background. You're not limited to just these modifiers. You can actually create your own custom modifier. So that's pretty cool. Now, you may be thinking that, isn't this just the same as changing the view's properties? Like in UIKit, you had a UI label. You can change text to whatever you want. You can change the text color by changing the properties. But these are a lot different from changing the properties. Because SwiftUI views are structs, you know that everything is immutable. You can't change its properties. And so when we're applying this modifier, what SwiftUI is really doing in the background is that it's creating a brand new view. So for every modification that we add to our view, we're creating a brand new view because structs are immutable. And you may think that performance is an issue because you're deleting this view and creating a brand new one, but Swift does this very, very fast and so frequently that you don't even need to worry about it. So now I'm going to demo. You guys don't need to follow along. I'll just show you how modifiers work. All right, so looking back at the example, we wanted a, show it. Yeah, we wanted a text with a red text color, a large font. I think it's not here. It's, yeah, right here. A black background, a padding of 20, and a font size of 24. So I'm just going to quickly demo how to do that in SwiftUI. Give me a second. Okay, so can you guys see the preview, or do you guys want me to enlarge it a little? Is it good? Larger? All right. Better? All right, so to create a text color, you can use a dot foreground color modifier. And in the example, I wanted it to be red. So I can just do dot red. And as you can see on the right side, the text color changes to red. Now, I wanted a font size of 24. So you can do dot fonts and then do dot system. So to use the system font. And I can use a size of 24. So you can see that the text got bigger. And then I wanted a black background. So I can do dot background. And inside of that, I can use dot black. So there's a dot background. And I wanted a padding of 20. So I'm going to do dot padding of 20. And if you don't provide anything, this dot padding modifier, there's like a lot more to it. But if I just do dot padding with 20, it adds a padding on all sides. But you guys notice that on the right side, there is no padding, right? And the issue is that, remember how we're creating a new view every time we're adding a modifier? What this is saying is that I have a text with a color of red. That's a new view. And then when I do dot font, I'm saying give me a text with a color red with a font size of 24. Same thing with the black background. But when I do dot padding 20 right after I add the background, what's really happening is that you create a black background, but then you add a padding on the outside. But I want the black background to have some padding. So I have to reverse it. I want dot padding to be before the background. So let me switch back. So as you can see, the order in which you use these modifiers matter. And because every time we're adding a modifier, we're creating a new view, then what's the actual return type of these views? Well, you can see that this is a view, this is a completely different view, but we don't know what the actual return type is. So I'm going to demo. I'm just gonna copy this code. All right. All right, so what I have here is a button with the word hello in it. And inside of that, if I were to click on the button, it would print out the type of this body property. And there's a padding, and then there's a frame of 200 or a width of 200 and a height of 200. So I'm going to run this and see. Come on. All right, so I'm going to click on this button, and in the console, this is the type of this body property. As you can see, it's very, very long and complicated. If I were to just add another modifier, if I do .background is black, and I run it again, there's a black background. Click on it. You can see that the return type was different from what it was before. And the reason is because we're creating a new view every time. So now what is the actual return type of this body property? Well, we don't know. It could be very complicated. And that's why we give it a return type of some view, because we don't know exactly what the return type is. We just know that it's some view, literally some view. So we learned that SwiftUI is a declarative framework. If we wanted a view, we declared that we wanted a view. There are a bunch of views that SwiftUI provides for us, but we also learned how to modify the views, add a background color, change the color of the font. But when we create apps, we don't just care about creating these views. We want to lay them out. We want to put them side by side. So how do you lay out views in SwiftUI? If you guys are familiar with SwiftUI, you may have heard of H stacks, Z stacks, and V stacks. If not, that's fine. I'm going to go over it right now. But before I go into it, does anyone have any questions? All right, cool. All right, so remember, everything in SwiftUI is a struct. This is a struct. It is a view. It is a view that contains other views, but it lays it out horizontally. So H stands for horizontal. So I'm creating a stack, similar to how in UIKit you have a stack view. But here I'm creating a horizontal stack. I give it a view, a text called Cornell, and text with the word app dev in it. And by putting it inside of an H stack, it lays out horizontally for us. So to answer your question about table views, collection views, if you had, I guess, a 3x3 grid, there's also this thing called like a grid, but you can also do it using this example. You could just create a stack containing these other views. Another stack is called a V stack that lays it out in a vertical manner. So if I put the text Cornell and the text app dev, it lays it out vertically. And the next stack is a Z stack, and it lays it out on top of one another. So you start off with the thing that you want behind everything, and as you're adding on top of it, or if you're adding code below it, it adds it on top of it. So I have the color red and the text app dev. In the text app dev, as you can see, it's on top of the color red. And on the top right, I put, I guess, like a side note. These views can only contain up to 10, I guess, views. And that's pretty, it gets into like the complicatedness of SwiftUI. There's like this tuple view. You guys don't need to know that, but just know that you can only store up to 10 views, but you can go around that by grouping them. So I can use a group to group these, and it makes them into one view. Or I can use, I guess, another stack. So you don't really have to worry about those 10 views thing. It's actually kind of nice because it allows you to break down your code and make things a lot more neat. And another common view or another common struct that you can use is a spacer. And I have a horizontal stack with the text Cornell and the text app dev. But in between, I have a spacer view. What this does is that it basically expands out the entire area as far as it can. So in UIKit, you have like these constraints, auto layouts, but in SwiftUI, you don't care about that. If I just add a spacer in between, it spaces out for me. If I wanted a space right here, I can just put the spacer before the text Cornell. If I wanted to the right of appdev, I can just put it after. You can also combine spacers. So if I have two spacers before here, and then another spacer in here, it will squeeze everything to the left, but there's the two spacers before, which will squeeze it back. And because there are two of it, it will push it a lot more. So you can just, with SwiftUI is really nice because it's very intuitive. I can just space things out as much as I want. And there are a lot more views that you can use to lay things out. There's this thing called a lazy H stack and a lazy V stack. I won't go too much in detail about it, but if you're interested, you can always come and ask me right after. There's also a list, which I will talk about in the demo. There's a scroll view, and then there's these grids, which is similar to a collection view. That you can have a form, and then there's a divider. There's just a lot of views that SwiftUI provides for us. And so now I will go into a demo in which we will be building a, I guess, bird watching app. Did you guys get to download and install Git? All right. So we'll be using Git for this demo. If you guys don't have it installed, no worries. I posted the source code in a zip file on Ed Discussion, so you can go ahead and download that. These are different branches. You guys don't really need to know what branches are, but I'll quickly show you guys how to check out a branch. Let's see. All right. All right. All right, so, oh, yes.
Yeah, I had a question about, like, the return type of some view.
Mm-hmm.
So if you know that it's going to return, like, view, it'll, like, cast it as that. Why do you need to use, like, the keyword some?
Yeah, well, remember how in the demo earlier, you see down here, that is the type of the view.
Mm-hmm.
I could have just copied that and then put that inside of some view, but when I'm adding a modifier, I'm creating a brand new view. And not only that, I can also put more text inside. And so you don't really know what the return type is. It can be very, very complicated. It could be like a million characters. But you do know that it is some view. You don't know exactly what it is, but it's some view. And that's why you need this some keyword right here.
Okay. So is it basically like if you have like a subtype of view, but you don't know like which subtype, it won't just automatically cast that to a view if you don't use some?
Well, SwiftUI doesn't really cast it. It's more of a, this is its return type. It's not exactly a view, but you know it's just some kind of view. All right. So this is the, or yeah, I'll show you guys how to check out our branch. So if you go into terminal, go inside of the repository, or I think it's yeah, so I have a repository called BirdWatch. If I want to check out a branch, I can just do, so like right here, I have 1-layouts, 1-list, 1-refactor. You guys don't need to do this yet, but if I wanted to check out the 1-layouts branch, I can do git check out 1-layouts, and it'll just switch the branch. And the reason why I'm doing this is that if you guys do ever get behind, you can just go and check out this branch and you'll catch up. All right. So I'm just going to check out the main branch again. All right. So before we actually create this, because we're using a declarative approach, it's important that we know how, or like we provide kind of like steps to how we're going to do this. So first, I'm going to create this individual cell. You can kind of think of this as a UI table view cell. And so I can see that these things are laid horizontally. So I will use an H stack with a text. But inside of that H stack, I'm going to have a V stack because these views are laid on top of each other. And then on the right, I'll have an image. So, right. So I first want to create that number 7. So I can use a text. Inside of that, I'll give it a string of 7. Just gonna refresh this. There you go. Okay. And in the image, it was like a little bit bigger. So I'm going to give it a font of .large title. And the really nice thing about having these, I guess, like built-in sizes is that when you're doing, when you're working with designers, it's a lot neat to just kind of use these built-in sizes. So I give it a font of .large title. As you can see on the right, it enlarges. And I want it to be bold, so I can do dot font weight and give it a weight of bold. And so now I have that text. And now I want this vertical stack containing the name and the location of that bird species. And so I would create a V stack containing a text. And for this, I'll just put my name, then. And I will put another text underneath that. And the location, I'm from Texas, so my bird species is from Texas. And so you guys notice that there's 2 views here, and it's not on the same, I guess, canvas. And the reason is because you can only have one thing in here. It's some view, but I'm having 2 views inside. And so I was missing an H stack. That way, you're only returning one view instead of a text and a V stack. So now everything is nice and neat on one canvas. Okay. But I want this text to be kind of aligned to the left. So what I'm going to do is add an alignment of dot leading to this vertical stack. And I want this text, the name, to be bold. So for my name, I'm just going to do font weight of dot bold. And I'm going to add another weight for Texas. I'm going to use dot medium. And the neat thing about having these weights is that if you guys work with designers with Figma, a lot of the times they use like SF Pro fonts, and there's like this weight of medium, bold, blah, blah, blah. You could just simply just use dot bold and dot medium. So it's really neat. Okay. So now, in this case, it was italicized, so I can do dot italic to italicize it. But I kind of want this text, both of these texts, to be a lot bigger. So instead of adding or changing the font size to my name and Texas, I can apply it to the vertical stack. And what SwiftUI will do for me is apply that modifier to every single view inside of it. So I'm going to do dot font of dot title. I'll do title 2, so not that big. Okay. And whenever you're creating apps in SwiftUI, it's really crucial that you space out with new lines of all your different views. So I'm going to add like a new line here just to space things out so that I know that there's 2 views inside of this V stack. Okay. So now I want this image. So after this text, after this V stack, I'm going to add an image. To do that, I'll just do image, which is another view. And then inside of that, I'm going to provide a name for it. If you guys have the source code, I have all these assets in here. And so you can just simply put in the name. For me, it's Vin. Okay. But that's a little too big. So I'm going to change the size by doing dot frame. Give it a width of 100 and a height of 100. I'm not going to go too much in detail about all the different modifiers. There's like a crap ton of them. You can always, the thing about SwiftUI is that it's very easy to create views. So you can always just like Stack Overflow it. But it's important that you understand how SwiftUI works and how to create apps in SwiftUI, because it's a lot different from how you create it in UIKit. Okay? But you notice that the image did not get bigger. And the reason is because there's this modifier that I need to add called dot resizable. And now the image is resized. I want a little bit of a padding right in between here. So what I'm going to do is, after this text, do dot padding. I want it at the end, at the trailing anchor. So I'm going to do dot trailing and give it a value of 30. So that looks good. But then I want this space right here. So does anyone remember what view I used to create a space in between? Spacer, exactly. So remember, create 2 new lines above and, or a line below, above and below. Spacer. And because spacer is a view, you want to add these new lines. So you can see that everything's stretched out. It doesn't really look like this, but because we're going to embed this inside of a list, we don't need to worry about that. So I think I'm done with the layouts. Does anyone have any questions? Yes.
Yeah, I'm having trouble getting my preview to load.
Yeah, is it saying like preview is paused or something?
Yeah.
Yeah, if you, there's like an arrow on the top. If you click on that, it should refresh it. Yeah.
I click on it and just keep saying loading iOS 16.2.
Yeah, and it,
Failed to build the scheme.
yeah, in that case, you might have to run it. Like, have you tried running it? Like, instead of using the preview?
It says for iOS device.
Mine says a build only device cannot be used to run this target. Yeah.
It might have something to do with, I guess, the compatibility issues. Yeah, so with this canvas thing, there's a shortcut. You can do Command Option Enter to kind of hide and open it. And to reload it, you can do Command Option P to reload the canvas. Alright, so if you were unable to catch up, like I said, you can check out the branch. So if you do git checkouts 1-layouts, yeah, so it says please commit. So what you want to do is do git add dot, and then you can just commit it -m. You don't need a message to commit. Oops. Okay, and then I can check it out. There you go. So if you check it out, it should be up to date with mine. Okay, so now I want this thing called a list. It's another view. So what I'm going to do is I'm going to remove all of this inside another view. And the neat thing about SwiftUI is that I can create another view and nest other views inside of it, and then just call the name of that view. So down here, I'm going to create another view property. It's good practice to call everything private unless you don't need to. So I'm going to call it a private view. And it's going to be a private variable. I'm going to call it bird info row. And its return type is some view, just like how the body is. And then I'm just going to cut this and then paste it into here. Right. And so now you can see Xcode is angry at me. So I need to call this view. So you can just do bird info row. So now the error messages go away and everything looks the same. And so when you're building like large scale apps, you can just create a view and then just call it inside of this main view. So basically everything that you want to show in your screen, you have to put inside this body property. You have to. But you can also break it down into sub properties as well. But as you guys can see inside of this list, there's not just me, there's Han, there's Elvis, there's Alden. So I need to, I guess, pass in these names or these images. So instead of a property with a variable, I'm going to use a function. So I'm going to change this to a function called bird info row. It's going to take in some arguments. I'm going to pass it a name, which will be of type string. I'll give it a location, which is a string, an image, which is a string, and then the count would be an int. And because it's a function, you need a return type. So instead of this colon, I use an arrow. Similar to how you have properties that have a return type of some view, you do the same thing with functions. And Xcode is mad at me because I'm calling this function right here, but I'm not passing anything into it. So, actually before I move on to that, I'm going to use these parameters. So instead of 7, I'm going to use counts. Instead of, instead of then, I'm going to use my name. Oh yeah, because this is an int, you need to cast it to a string. So string count. And then Texas, I'll use location. And then the image name would just be image. Alright. Alright. So now, if you guys look inside of bird.swift, I have an array of birds and a struct containing these properties. And so what I'm going to do is ignore this message for now. What I'm going to do is create a list. So I can do a list. And I need something to iterate over. In here, I have an array of birds. So I'm going to pass in birds into it. Or birds. But whenever you guys used a UI table view cell, what else did you need? Or a UI table view, what else did you need?
Custom cell.
Yeah, custom cell. But whenever you're scrolling, these cells get dequeued. But how do you know which cells are being dequeued? What kind of thing did you have to identify it? Yeah, a reuse and identifier. That's how you identify these cells. In SwiftUI, you kind of need the same thing. So I will add a comma, and the identifier, you can use whatever you want for the identifier. Inside of this bird object, I can use the name if I want to, or I can use the location, whatever I want. But you can use the actual object itself. So I'm gonna do \self to use the actual object. All right, and then use these curly brackets. Inside of that, I'm going to put bird info row in there. And because bird info row is a function, I need to pass in these name, location, image, and counts. So remember how earlier I iterated over this list of birds? Well, I need to grab the actual bird object. It's a list of birds, but I want the individual bird object. So to do that, you can just do bird in. It can be whatever you want, but usually it's a good convention to call the singular version of that array. I'm gonna call bird in, and then inside of bird's info row, I'm going to pass in for the name. Remember, this is a bird object, so I can do bird.name. For the location, bird.location. For the image, bird.image. Count, bird.count. Alright. But now, Xcode is mad at me. So if I hover over this message, it's saying that bird needs to conform to hashable. So because I'm using the actual bird object itself as the identifier, I need to conform this struct to a protocol called hashable. Additionally, I can use the identifiable protocol, but Xcode will yell at me because I need an ID property inside of here. But in this case, I'm not going to use an ID. So to go around that, instead of identifiable, I'll conform this bird object to codable. If you guys remember from the networking lecture, you have an object that you can decode using the codable protocol. So similar to, in this case, conforms to codable. So now if I switch back, hopefully, yeah, Xcode is not mad at me anymore. And there you go. And the cool thing about this preview is that you can actually interact with it as well, which is very, very nice. So these are my birds that I've spotted. So now, one more thing that I'm going to do is I will make my code a lot more neat. So does anyone have any questions? Yeah. So to catch up, you can, again, I'm going to add these files and then commit some random message. And I'm going to check out the, one-list branch. So if you're behind, go ahead and check out this branch. All right. So what I'm going to do now is when you're dealing with large-scale apps, you're going to have inside of this project navigator a bunch of views. And so I will create in here a new file. I'll use SwiftUI view here. Next, I'm going to give it a name. I will call this, because this is a list, I'll call it a bird list view. Create. So this is just a brand new view. Notice how this is similar to content view. All of the views that you create, all of the code that you write in SwiftUI will literally look just the same as the content view. They're all some view. Yes.
Do you mind going back to the command to catch up?
Yeah. All right. So you can do git add and then space dots to add all of the, to stage all of these files. And then you would do git commit -m and then the message. I'm not going to go over what this does, but just commit any message. And then you can do git checkout -list to check out that branch. And it'll allow you to catch up, yes.
My preview is all like 7-bin Texas. It's like the same content.
Oh, did you use like a list? Or are you talking about like after checking it out? Or
Like, I think I followed up to now.
or like this? And it's still like it doesn't have this?
I added that.
Oh. And it's still not showing the list and stuff?
No, it's showing just bin. But
Yeah.
repeat it.
Did you pass in parameters for the text?
Oh, no.
Just make sure you pass in these, because you're looping over this list of birds, grabbing the bird object, passing the bird's name and stuff to this function. Okay. So inside of bird list view, what I'm gonna do is I'm just gonna copy and paste this entire code inside of here. So copy and paste that there. So this is exactly like content view earlier. And so now in here, instead of having all of this nonsense, I can simply just call that view that I created earlier. So I'm just going to delete this list, and I can just call it bird list view in here. And just like that. So when you're working on your hackathon, if you do use SwiftUI, it's nice to break all of your views down into a bunch of different files and use it and just call it in another view. All right. Yeah, that's basically it for this demo. Next lecture, I'll discuss how to communicate between views and how to modify the program states. So yeah, there's going to be a Kahoots.
Actually, I'm not going to present the Kahoot today because we went a bit over time, so I don't want to keep you guys any later. But yeah, can I get a round of applause for Vin's first lecture ever? Great job, great job. Just some few quick announcements. So this Friday is when P7 is going to be due.